Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome again. This is inshallah Rabbil Alameen, the second part of our mini revision. The second part in our mini revision, we will talk about the principle or the elementary concepts of the kinematics. Before everything, we have to differentiate between the kinematics and dynamics. What's the difference between kinematics and dynamics? The kinematics, it's a branch of physics that describes motion. It just describes motion. It just describes motion. It doesn't talk about the cause of motion. What did that? What does that? What talks about the kinematics, the reasons of motion? It's the dynamics. So the dynamics, it studies the reasons or the causes of motion. What does it mean, causes of motion? Force, for example, is the cause of motion. But describing motion in kinematics is just talking about the distance, displacement, the velocity, the speed, and the acceleration. Well, so the first quantity in dynamics or kinematics is the displacement. The displacement may take the symbol delta x or delta y. What is the displacement? The displacement is the change in position. This is the too short form of the definition. Or in other words, remember we can say it's the straight length from the initial position to the final position. This is another definition if you remember, okay? But here we wrote anything too short to revise as large as possible, as large amount of information as possible. The measuring unit or the SI unit of the displacement is meter, okay? But this is the SI unit, but it doesn't mean that there are no units else. We have a kilometer, we have centimeter, and so on. Okay, you have to remember the following: to change from kilometer to meter, you have to multiply times 10 to the power of 3. To change from centimeter to meter, you have to multiply times 10 to the power of -2. Well, so the displacement is a change in position. It's a change in position. And we said it's vector quantity. What's meant by vector quantity, Mr.? Remind me. Vector quantity means the quantity that has a magnitude and direction. So in the exam, if I ask you to find the velocity, the displacement, when the object is moving to east, for example, don't say the displacement is 5 meters. You will lose half the mark. Why? Because you didn't give me a complete information. You didn't give me complete information about displacement. You have to say 5 meters right or 5 meters east and so on. What about the distance? The distance is the real or the actual total path length, the total path or length traveled by the object. By the way, and this is a very important point, in problems, concentrate with me, in problems, the distance and displacement will be the same because, or only if the object is moving in a straight line. So any problem that shows you the object is moving in a straight line, you can use displacement, distance, or in other words, displacement, the magnitude of displacement, which is distance. You can use any one instead of the other, and so on. Okay, well, so what about the velocity? Displacement divided by time will be velocity, but distance divided by time will be speed. And anything divided by time, we call it time rate. So the velocity is the time rate of changing position. It's time rate of changing position or time rate of changing displacement. Well, time rate of changing anything is the change in this thing divided by time. So the velocity is delta x divided by delta t, as you see. Is velocity Vector or scalar? It's vector. Why? Because it's displacement over time, and the displacement is vector, and the time is a scalar. So vector over scalar, the result will be vector, which has a magnitude and direction. Well, what is the measuring unit of it? Displacement is measured in what? Is measured in meter, yes. Time is measured in second, yes. So the SI unit will be meter per second. Can it be any other units? Yes, it can be. It can be what? It can be kilometer per hour or mph. Wow, what does it mean, mph? Mr. mph means meter per hour? No, it means mile per hour. It means mile per hour. Well, here we will talk about the graphing of velocity. We said that the graphing of velocity, we will put the time on the horizontal axis and the displacement or position on the vertical axis. So this shape will be, or this graph will be called position versus time graph. Position versus time graph. Well, and we said in naming the graph, we mentioned the first, we mentioned the vertical axis first, then the horizontal axis. If we plot the x and t as it's shown in the graph, if the curve is straight line, if the graph is straight line, it means the slope is constant. Okay, what's meant by slope? Let's remember. Look up here. Slope is rise over run. The slope, if you make position here and time here, the slope is v. The slope is v. But if you put the velocity here and the time here, the slope is a, which is acceleration. You have to remember that well. Again, so in this case, the slope is constant, so it's uniform velocity, and it's positive because the line is going up. Okay, not up. The line is going ascendingly. Okay, so it's positive. Here, what does it mean? It means it's zero. The slope is zero because the line is horizontal. So the object here is at rest and the velocity is zero. Okay, here it's variable velocity, but you have to observe that variable because the slope is varying well. But if the line is going in this direction, it will be positive. When it's in the top, it will be zero, negative, zero, positive, zero, and so on. But be careful. Look here with the pointer. In case of acceleration, the acceleration is the time rate of a changing velocity. So here time rate of a changing velocity, here time rate of a changing position. It's so easy to compare between them. The acceleration is change in velocity, which is v final minus v initial divided by t. What's v final? V final, what's vf? It's v final. What's vi? It's v initial. What's delta t? Delta t is the time interval. Okay, so what about the measuring unit? The measuring unit is meter per second because the velocity is a meter per second. Time is another second in the denominator, so the velocity, the acceleration is meter per squared second. Well, here, what is this? Someone may say, Mr. Don't say, I remember, it's a constant velocity. No, it's constant acceleration. Why, Mr.? You said it's constant velocity. It's here. Constant velocity, you said. No, this is displacement or position versus time gives the slope as velocity. But here, this is velocity versus time. It gives the slope as acceleration. You have to observe that. So the first thing you have to look at when you look at the figure or the graph, I'm sorry, you have to look at the two axes. If it's x versus t, displacement versus time, position versus time, the slope is velocity. So you are talking about velocity. If it's velocity versus time, the slope can never be velocity because the velocity is one axis. Okay, so the slope here will be acceleration. It will be uniform acceleration if the slope is constant or a straight line. Here, the slope is zero because the line is horizontal. So it's not rest, by the way. This is rest because we have x here. We have x here. But here, it's not rest. Why? Because we have v here. So what does it mean? It means the acceleration, which is the slope, is zero, and it's uniform velocity. Well, what about this? It means the uniform acceleration also because it's straight line, but it's going descendingly. It's going down. Okay, so it's negative. In this figure, the displacement under the area equal the, the area under the curve equal the displacement, and the acceleration is the slope, which is rise over run. Now you have to memorize, you have to memorize these four equations, which are called the kinematics equation, like your name. Like your name. Vf equal v initial plus acceleration times time. X equal half v initial times v final times time. Vi times time plus equal half 80 squared equals also x also. V final squared equal v initial squared plus 2ax. Well, in free fall, the free fall is considered to be a uniform acceleration. These four equations, those called kinematics equation, are allowed to be used only if the acceleration is uniform or constant or steady, which means the magnitude of the acceleration is constant and the direction is straight line, or the motion is in a straight line. Well, so, or in other words, the acceleration is always in the same direction and in the same magnitude. Even the motion changes its direction. Mister, I think you have to revise what you are saying. No, I mean it. I mean it because it will represent a very important note, inshallah Rabbil Alameen, when we throw an object up to make and let them to fall down again. Okay, well, but it's not our point. Our point now, you have to memorize these four equations like your name. If the object is falling freely, you will change x to y because it's vertical motion, okay? And the acceleration is negative g, is negative 9.8, 9.81, 10 meter per second squared. It's always negative, even if the object moving up or down. Well, if the object is moving up, remember, moving up, so the velocity and the displacement both are positive, but the acceleration is negative. So it decelerates because the sign of acceleration is opposite to the sign of the initial velocity. If your object is moving down, the displacement is negative because it's moving down. We agreed together that down is negative, up is positive, right is positive, and east is positive, west and left is negative, and so on. Okay, x is will be negative because it's going down. Initial velocity is negative because it's going down. But be careful, the acceleration is negative. It had the same sign as the initial velocity. So the acceleration supports the initial velocity. So it's speeding up. Really? Yes, we know that when we throw an object up, it will decelerate. And when we release an object to fall down, it will accelerate, speeding or speed down. Be careful. These are keywords in any problem. When you say in the problem comes to rest, it means V final is 0. When you see starts from rest, it means V initial is 0. Well, the signs rule, to know if the object speeds up or slows down, we have to look at the sign of initial velocity and the sign of acceleration. Well, if they have the same sign, it's speeding up. Allahu Akbar, Allahu Akbar. It means they support each other. Allahu Akbar, Allahu Akbar. Okay. It means it supports each other. Well, so uh, initial velocity is positive, acceleration is positive. If they are positive together, it means the object is accelerating, speeding up. Sorry, in other words, because accelerating means may mean slow down. By the way, okay. Negative and negative, it speeds up. Someone may say, "Mister, you mean it?" Negative acceleration gives speed up. Yes, this is if the initial velocity is negative. But what about the initial velocity is 0? If the initial velocity is 0 and the acceleration is positive or negative, it means the object will move. So it means its velocity will increase in positive direction if it's positive, or in negative direction if it's negative. But what about if the two objects are if the two quantities, acceleration I mean, and initial velocity, are opposite to each other? What's the point here? It's slowing down. So if the initial velocity is positive and acceleration is negative, the object slows down. If the initial velocity is negative and the acceleration is positive, the object slows down. Someone may say, no, mister, acceleration is positive and the object is slowed down. Yes, acceleration is positive and the object slows down only if the initial velocity is negative. So acceleration is positive and the object slows down only if the initial velocity is negative. I'm sorry for speaking quickly because I want to save time as possible as it. Here, by the way, if the acceleration makes speeding slowing down, sorry, if the acceleration makes slowing down, we will call it deceleration, as we said, deceleration or retardation. Well, now, inshallah Rabbil Alameen, we will talk about examples on this, but in the next video. Thank you, everyone.